Good morning everyone, welcome to the homework portal. This is week 5. Now we will be solving questions, 5 questions. This is for the IB1 and of course this will also be for IB2 SL students. Okay, so these set of problems will be published one problem per day and this is from 30th September, that is tomorrow, to 4th October. So this is what we have. Okay, now let us begin with the questions. The first question is from mechanics. As you know, from next week onwards you have the test coming into the midterm exam. So as a result of this, we should solve more number of questions. Anyway, this is also a revision. So don't waste your time. Do continue solving these problems. So one problem per day will always help you out to solve more number of problems. And if you keep on continuing like this, I hope we will be finishing all the problems related to your IBDP past papers within this year itself for IB1 and IB2. I think almost from 2016 to 2023, whatever papers has been published so far in the IB portals, we can easily finish it up within this time. Okay, now let us not waste our time. Let us continue with this. So this particular problem is for 9 marks, so I have allotted for 9 minutes to solve this problem. Okay, let me start with this. So the first question is, this question is about finding a force that acts upon a car when it is in a head-on collision. Okay, a car comes and hits onto a wall. In order to measure the collision forces, a car is crashed head-on to a flat rigid barrier and in the resulting crash distance d is measured. So the moment it hits over here, what is the resulting distance? That's what we see. The crash distance is the amount of the car collapses in coming to rest. In the above diagram, the crash distance is d equal to L1 minus L2. So what happens is, initially when the car is stationary over here, this is the length L1, and when it crashes onto it, this is the length L2, right? The part of it is got damaged over here, right? Then show that the average crush force exerted on a car of mass m with impact speed v is equal to mv square by 2d. So how do you solve this? So towards it, see, why does this car gets crushed into parts? Because it's an applied force, right? So therefore what we do is, what is the work done by the car? The work done by the car here is nothing but applied force multiplied by the distance in which this has moved over here. This should be equal to the difference in kinetic energy. What is it I have applied? I have applied your work energy theorem. So what is work energy theorem? Work energy theorem tells you that the change in potential energy is equal to negative change in kinetic energy, or negative change in kinetic energy is equal to negative change in potential energy. How do you get this? This is a consequence of the conservation of energy, right? So therefore, what do we say about it? We can say that now is that okay, F into D is equal to change in kinetic energy. What is change in kinetic energy? The initial kinetic energy was 0 minus the final kinetic energy was minus half mv square. So this should now be equal to, minus into minus becomes plus, this should be half mv square. What is it we need? We need the value of v here. So therefore, we need the value of F here, crush force F here. So thus you have F should be equal to mv square divided by 2d, right? See, this d I am transposing it downwards. As a result of it, you get the value of F over here. Thus the value of F we have obtained here already. Okay, let us move on to the next question, second question, right? The table below gives the value of the crush distance d for the different impact speeds v of cars of same make. Uncertainties in measurements are not given. Okay, so v is given, d is given, v square by d is given. Okay, you need to fill in these values. How do you fill in the values? So we need to calculate the values of v square by d. Let us use my calculator, right? So we got the calculator here. So let us find out what is this value, v square. What is v square here? 9 divided by, what's the value of d? 0.08. 0.08. What is the answer I get? I get 112.5. Nothing else, but only thing is you need to just fill in the value 112.5. okay, and then the next one, 10 square 100 divided by 0.35. 0.35. So how much does it get? 285.71. I'll write this as 286. Then 15 square is 225 divided by 0.65. How much do you get? This is 346.145. 346 I'll write here. And 20 square is 400 divided by 1.02. 1.02. So how much do we get? 392.15. I'll write this as 392 here. Okay, so I've already done this. How much marks does this carry? This carries 1 mark over here. Okay, so you have completed the last column completely, right? And then nothing but calculation. On the grid plot below, plot a graph of v square by d against v. These are 4 marks. Okay, so therefore v square by d against v. So v square by d will be plotted along the y-axis and v will be plotted along the x-axis. V will be plotted along the x-axis. So towards it. Now how do we do this one here? Let me reduce this a little bit so that I can also view this. Okay. So now how do we plot this? We can plot it like this. So we can see, we can write it like this over here. We can now, we have to choose it, the values. What is the value? Maximum value is 392 or 400. Minimum value is 0. Okay. So therefore, how many squares do we have here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 squares over here. What we will do is we will choose one square is equal to 50 units of v square by d. Okay. When I use something like this, now what will happen? This will be your 0, this will be 50, this will be 100, 150, 200, 250, 300, 350, 350, and this is 400. Okay. So I'll write down the maximum point. 400 here, 350, 300 here, then 250, 200 here, and I think the rest of them is fine. And similarly, what do we have for v? The value of v varies from 0 to 20. 0 to 20. So again, I'll choose something like, I have chosen 5 here. Okay. So I will choose something like 5 here. Shall I choose 5 here? I will not choose 5 here. I choose 5 here. 2 squares, 5 units. 5 here, 10 here, then again 2 more squares, 15 here, then again 2 more squares, 20 here. Now we have chosen the scales uniformly and we have got the axis over here. We have labeled the axis. So we have to label the axis, which will carry 1 mark over here. We have to choose the scaling, proper scale is being chosen, so you get 1 mark over here. Because 4 marks, right? We should appropriately choose it. Right. The next one, what is the value here? Now you need to plot. What are the plots here? 0, 0, 0, 3, 112.5. 3 is 112.5. Where does 3 come? This is 2.5, this is 3, and 112.5 would be somewhere over here. Somewhere over here. This will be 112.5. And then what's the next point? Next point is 10, 286. 10 and 286. 10 and 286 is 200, 250, 275, 280 would be somewhere over here. 280 would be here. And then next one is 15, 346. 15, 346. 15 is here. Then 346, so 300 is here, 346 here. Somewhere closer to 350 should be your answer. Somewhere I'll put it over here, 350 over here. Okay. And then the last one, 20, 392. 20, 392. 20 is here, 392 comes out to be, this is 4 here, 400 here. So 392 might be here over here, right? So therefore, now we have plotted the points also. So for plotting the points properly and showing it correctly, by either by a dot or by a star, will give you 1 mark over here. Then what's the next step? You say complete the last column. Okay. On the grid, plot a graph. What do you mean plotting? Plotting means there should be a line plot. Okay. So I will draw the line plot over here. Let's start from here. Draw a smooth curve like this. Draw a smooth curve like this, which passes through all the points properly. In fact, I have not drawn it. See, because it's passing a little bit away. Okay. It should actually pass like this over here. It should pass like this over here. Okay, but don't take abrupt corners over here. So it should be a smooth curve. Okay, we have drawn this. Then consider a situation in which a car of 1200 kg mass is equal to 1200 kg and the impact speed of 12 meter per second. Okay, use information from the graph. You have to draw the average force exerted on the car during the collision. So he is asking you to find out the average force. Now, what is this about V versus V square by D? So what is the relationship connecting force versus the V? So is there a relationship? See, in IB, all the questions are being asked in such a way that the solution for it will be hidden somewhere here itself. Okay, there will be a clue given here. You need to find out and search for it. Now here you see this F is equal to V square by D into M by 2. MV square by 2D. Okay, let me write it down here. I can say F is equal to mv square by 2d, which we already got. We'll write this as m by 2 into v square by d. Now what is that we have? We have an impact speed of 12 meters per second. At 12 meters per second, can we find the value of v square by d? That's the question. Now look at this. There is 10 here, 10 is here, 12.5 is here, 12 is somewhere over here. This close line here. When it comes here, it will go and hit somewhere over here, right? So it will join this line. So this will come out to be somewhere at this point over here. So how much is this? 300, this 350. So maybe 5 points over here. So it should be 5 points, 10 points over here. this value should be 310, right? So therefore, now what I will do is v square by d is equal to 310. What's the value of m? M value is going to be 1200. 1200 multiplied by 310 divided by 2, which will be equal to how much? Let us calculate that also. 1200 star 350 divided by 2 will be 210 000. 210 000, which would be equal to, what is this now? Newtons, right? So which should now be equal to 210 kilonewton, right? Anything else we have missed? We have not missed anything, right? So therefore the answer should be 210 kilonewton. Now, what is the marking scheme says? Marking says accept anything between 1.9 to 2.1 into 10 to the power of 5 Newton. Is it 2 power 10 power 5? Yes, you see here 210 kilonewton is nothing but 2.1 into 10 to the power of 5 Newton. So therefore our answer is correct. Okay. So thank you. So let us see once again in the next video. Thank you.